In a world full of mysteries, a groundbreaking device reveals the secrets in the universe. The James Webb Space Telescope, JWST, known simply as Webb or JWST, is a pioneer in providing spectacular views of the stars, planets, galaxies, and other wonders of the universe. As the successor to the Hubble Space Telescope, JWST has set new standards for scientific and dynamic observation. From one corner of the world to the other, people share photos or use raw data to create landscapes. Just 3 minutes ago, James Webb captured the most disturbing picture ever taken. It's been a year since the James Webb Space Telescope spectacularly revealed its first landmark image of the world, stunning astronomers around the world with its stunning details. However, the new discovery is an amazing picture of the universe, unlike anything we've ever seen. The discoveries made by the James Webb Space Telescope are more progress than ever before. According to scientists, the successor to the Hubble Space Telescope has revealed new information about star formation, galaxy mergers, and the early universe. Just a month after the first images were released, the images are amazing, showing the world in unprecedented detail. Since then, the number of discoveries has skyrocketed, providing scientists with a vast treasure trove of data. The James Webb Space Telescope's images of the magnificent Tarantula Nebula, record-breaking cosmic dust clouds, stars near their explosive deaths, and other awe-inspiring celestial objects have been meticulously cataloged. This satellite observatory's cutting-edge technologies allow us to peer further into space than ever before, unveiling previously unknown details about the universe. Some of these observations commemorate the first year of the James Webb Space Telescope's operation. NASA released an image showing a small star-forming region in the Ruchet Cloud Complex, depicting jets shooting from baby stars as massive clouds of different colors influence molecular hydrogen, which forms the red clouds. The existence of spherical disks around some stars suggests that planets may have formed in the past. It may look chaotic, but according to NASA, this beautiful nursery is small and quiet compared to others. The living stars in this region are about the size of our Sun or smaller, making it the closest star-forming region to Earth. The image was taken by the probe's main camera, the Webb Space Telescope Near-Infrared Camera, NIRCam, which takes stunning images in 2 distinct infrared regions simultaneously. In addition, telescopes have increased their understanding of exoplanets, or planets orbiting stars other than our Sun. James Webb was very good at studying distant galaxies. In early 2023, the observatory will discover its first planet, LHS 475b, 41 light-years away, and about the same diameter as Earth. According to NASA, the James Webb Space Telescope is the only operational telescope capable of analyzing the atmospheres of large-scale Earth. The findings show how accurate the telescope can be and make solid exoplanets a new frontier for astronomers. The James Webb Space Telescope also found evidence of ancient galaxies that should not exist. Swindon School's Evolution Laboratory and its team of planets have discovered 6 epic ancient galaxies known as universe breakers that will have a profound impact on our understanding of space. According to the results of experts, these giant galaxies may have appeared between 500 and 700 million years after the Big Bang. Recently, the infrared sensors of the telescope have revealed that we can look back for 13.5 billion years, when the stars and galaxies were very stable. The size of the universe breakers surprised scientists, as galaxies in the early universe were 10 to 100 times smaller than their current size. These 6 masses can be up to 1 billion times more massive than our Sun, and the total number of stars in the galaxy can be 100 billion times more than our Sun. Does the thought of trying to understand something important bother you? Despite advances in technology, the existence of planets this large has eluded experts. Nothing more than the discovery of a planet is considered too big for its star. This has led to a reassessment of our overall understanding of planet formation and planetary system design. According to Pineate's research, they have discovered a planet many times larger than Earth. The planet is thought to be in a planetary system around the supercool star LHS 3154, a star smaller than our Sun. Until they saw it, researchers didn't believe this phenomenon was possible. However, new evidence suggests that the largest planet in our solar system is orbiting one of the smallest and coolest stars in the universe, a very cold dwarf. There is almost no understanding of the world. The discovery that a planet of this mass orbiting a low-mass star defies our expectations. These stars may have formed in large clouds of gas and dust, and planets may have formed from the gas and dust left behind in the material disk surrounding the newborn star. However, the planet-forming disks around the low-mass star, LHS 3154, do not have enough solid mass to form planets. But it still exists, so we have to rethink our theories about the evolution of stars and planets. A good analogy is equilibrium. The internal temperature of the star must be constant with the external heat source. When the temperature of the hot spring drops, you need to get closer to it. The planets are the same. Planets must be hot enough to support liquid water and must be close to their stars. For example, Earth is in the habitable zone because of the heat and light that comes from the sun. The distances of different planets from our sun are either too far or too short for light to support life. Imagine a world with a very cold star. The same goes for planets orbiting a star that is cold enough to have enough energy to support life. The size of the planet must also be adjusted to provide the optimal distance for energy and light to support life. Going back to the previous discussion, there are many theories as to why this planet formed so close to the dwarf star. According to a popular belief, the planet may have been larger in the beginning. Over time, the world lost a lot of its mass. However, this theory is seriously flawed because due to the large mass, the planet has more gas than solid matter. In this situation, it is thought that most of the mass of the world is ash, which is not consistent with this finding. Another explanation is that this giant world formed far away from a small star. If the planet could block enough light, it would probably be covered in ice. This star may be pulled by this distant planet, so this giant planet will come close to the smaller star. Although both theories can explain the observed pairing between a star and a planet, scientists still cannot fully understand the strange phenomenon. With advanced technologies like JWST, scientists are exploring planetary systems in greater detail, and each new discovery pushes them forward. It dives deeper than the last 30 years into the state of the world in recent months. The vast amount of data provided by the telescope has led to major scientific breakthroughs that have amazed astronomers and inspired future space exploration. With the James Webb Space Telescope now in operation for a year, one thing is certain: the universe is more complex than we previously thought, and there are many questions to be answered. The James Webb Space Telescope, launched by NASA in December 2021, represents a major leap forward in our quest to understand the universe. Dubbed the successor to the Hubble Space Telescope, JWST is equipped with advanced technology designed to capture images of wildlife over a larger area than ever before. At the heart of JWST's capabilities is the large primary mirror, 6.5 meters, 21.3 feet in diameter. More than twice the size of Hubble's telescope, JWST can collect and focus more light. This light-gathering ability allows JWST to observe fainter, more distant objects with greater clarity and detail. One of JWST's main instruments is the near-infrared camera, NIRCam, which is essential for observing the universe in the infrared spectrum. Infrared light is important for studying celestial bodies because it penetrates clouds of dust in the sky that block visible light, revealing hidden stars, galaxies, and planetary systems. NIRCam operates in infrared wavelengths simultaneously, providing astronomers with valuable information on the temperature, structure, and motion of distant celestial bodies. Another important instrument on JWST is the near-infrared spectrophotometer, NIR-SPEC, which breaks light from distant objects into its various colors or spectra. By analyzing these spectra, astronomers can determine the chemical composition, temperature, and motion of distant stars, galaxies, and exoplanets. This ability is very expensive.